off. They're on, right? You guys ready to go?
All right, good afternoon, everybody. My name is Andrew Budke, and with me here is Brittany Greenwood. We are a couple of students, members of the team responsible for the Passive House exhibit over on the far side of the pavilion. Important thing that we're pretty proud to tell everybody is that that project is entirely designed and built by students, architecture students at NDSU in Fargo. And I say that that's important for this topic of reusing recycled materials because we're students and because we were asked to design the materials and all of the surfaces inside. We often turn to the easiest, simplest, cheapest thing we could find, and oftentimes that was even recycled. That's important for a few reasons. It makes sense financially, of course, if you can use these cheap products, but also it makes sense in terms of like broader energy use, right? If you can reuse or repurpose a material, that's energy that you don't have to invest and embody in a new material. So with that in mind, I guess we'd like to hop into some of these, showcase some of these materials that we came up with.
Okay, and like Andrew said, we did some explorations during the semester with recycled materials due to our limited resources, of course, and then the idea of embodied energy, using as many materials that we had absolutely as we could. One of those materials being glass. One of the first experiments we did was glass as aggregate in a concrete countertop. Not necessarily a countertop, but more of a surface. So we did some experimenting. We acquired some glass wine bottles. The restaurant I work at actually does not recycle the glass wine bottles. So we collected those, rinsed them out to eliminate all the sugar from the leftover wine, which would interfere with the adhering of the glass to the cement. And then we crushed them up and did some experimenting. We experimented with mortar, different ratios of bonding adhesive, concrete, cement, different ways to apply the glass. And what we found was the best mixture was just cement, glass as the aggregate, and a little bit of sand for a little bit more structure. And that was it. So here is a little bit more about our process. Here it shows one of our more advanced, I guess, processes of breaking the glass. We started with just using just a filling paste and a couple of hammers, and then, of course, protection and gloves. And here we advanced to a full bed sheet and plywood, and then multiple hammers, a little bit more efficient. Moving on is the mixing process. We used about maybe 60 to 70% recycled glass within our mixture. The other material being Portland cement and the clay sand, and then just a little bit of water. Here is our molds. We built 2 feet by 2 feet molds. They were 3 inches thick at the edge for extra support, supported or reinforced with 1/2 inch rebar, and then 2 inches thick at the base with 1 inch of plywood for a little extra support, and then to reduce the weight of the overall panel. This is the concrete being poured into the mold, and then using a trowel to push out the concrete into the corners to make sure that it's evenly spread out and consolidated to make sure that the mix is as solid as possible. Lastly, we seeded glass on top of the mixture. This was to sort of control the composure a little bit better of our finished product, and then to make the glass a little bit more easily accessible when we did venture out into the grinding process. This we used just a scrap 2x4 to do a little bowl floating, again to consolidate our concrete to make it as level as possible. And moving on, this is the vibrating process. We just use 2 hammers, super simple, and this was to eliminate all of the air bubbles and to consolidate our mix as much as possible so that we could have a smooth surface when we were finished. And we let the concrete cure for about 7 days, and then we brought in the floor polisher This is just your standard floor polisher, but what we did is we attached some diamond impregnated grinding discs. So the most aggressive ones we used were 50 grit, and they were steel and diamond impregnated discs, and they took the concrete and the glass down so that it was a smooth surface, and then we just increased our grit little by little until we were at about 3,000 grit. Once we moved past the 50 grit, they were just a resin and diamond impregnated disc. You can use them on just your standard hand grinding 4.5 inch grinder. A little bit more labor intensive, time intensive, and a little bit more difficult to get it that level surface, but it is something that everyone could have access to. And this is showing how we polished the smaller surface on the front there, which ended up being the front of our bench. This is the final installed product. We use this as a bench. The same process could be used to create a glass and concrete, glass and cement countertop, basically any surface really in the bathroom. Here it's used as a bench, so we did not finish it with anything. There's no sealer or no resin or anything on top of it. It's just the concrete smooth with the 3,000 grit grinding disc. Another material that we found pretty interesting throughout the semester was burlap. Burlap is a relatively inexpensive material, and it's a waste product, and it's made of woven hemp, flax, or jute. Some reuses for burlap are usually in the garden, whether it be plant transport, crops protection, erosion and insect control, or storing produce because it is a porous material. What we appreciate the burlap for is its light quality. We found that pretty interesting, and we tried to think of ways that we could sort of apply this in our building as a building material, whether it be for a screen on the interior or the exterior for an exterior screen to screen out insects. It's a very durable material. Or for panels in a wall partition, or we actually ended up using it as panels on our guardrail system. So there is stretched burlap with light behind it. We did some experimenting with the different ways light would transfer through, whether it be one layer of burlap or 2 layer of burlaps, and then different ways to support those panels. And then here is the process. It's just some 1x2s, a staple gun, and then you just stretch the burlap around that frame with a stapler, and you have a panel. And there are the panels installed in front of our guardrails, and then here's a close-up here. You can kind of see how the light filters through and creates sort of an interesting effect with the burlap and the guardrail combined.
All right, so Brittany just talked about a lot of the burlap that we're experimenting a lot with. Concrete we did a lot of experimentation with. So perhaps it follows then that we tried to combine the two at some point, and that's what this is. Burlapcrete, I guess, is kind of what we ended up calling it. So Brittany actually did some of the very first experiments with it. It's stretched burlap again, and we use different types of cement, whether it's pure Portland cement or grout, floor leveler. We also tried adding a latex additive, which you can also find at the hardware store. We tried all those things. We got a lot of different colors, some of them much darker than others. Also a lot of different textures. I think this one was using grout and burlap. You can see here how the burlap is sort of naturally resistant to any water or any liquid moving through it. So this is kind of the back side of pushing that mixture through. There's another one that's the floor level and mixture grout. Turns out it's actually a very, very strong material, just inherently. We wanted to see just how strong it was, so we started smashing it until we broke it. That was kind of our test. So what you see in this picture are actually holes from a hammer. That's what it took to break it, even though it's thinly stretched. So then we came across another waste material. I was printing off some construction documents, and one of the waste products of that is you get all of these cardboard tubes. So we took these, we glued them together into like this sort of board, and then we placed the burlapcrete over top of that. I think we used, was it floor leveler, I think, and the latex, and we dunked the burlap in there and then stretched it over these shape, and it was actually extraordinarily strong. If you look really closely here, you'll see a couple of, we took the hammer to it again. We couldn't break it this time, we could only dent it. It was pretty remarkable. It's fire resistant, it's a rodent resistant, water resistant. It's a really interesting material. I hope we'll use it in the future. A lot of people have been asking us over the past class today about the gabions. We have a sample down here, one of the first ones we made. Gabion is not necessarily a new material. It's essentially a steel cage that is then filled with rock. Very simple. It's typically used on a much larger scale, a civil engineering scale, canals, terraces, roads, things like that. Huge, like 3-foot cages filled with rock. We realized that we could take it down to a much smaller scale and start using it as a wainscoting, like a weather guard. A lot of times buildings have trouble right where they meet the ground with water, right? Either water fails to fall off the building or it starts splashing up and there's any wood there and it starts to rot and cause all sorts of problems. So a lot of times, or one strategy for that is to add a water shedding surface like stone wainscoting or something. So we started doing experiments with that. We ended up using, settling on a really easy material to work with, very readily available. It's just half-inch hardwired cloth that we got at the hardware store. Get it anywhere. Very easy to work with. We just use a wire snips and a hammer. That was about it. These were some of the very earliest versions that our classmate Mike worked on. Eventually we kind of settled on a smaller size, and then oddly enough it got bigger again. Kind of came full circle. Again, I said it's just a wire snips. We found a pretty good way of shaping them, I think. Bending them around a sort of pattern block, and then folding the metal and sort of tapping it to make sure that it would crumple in a certain seam. And so doing that, we were able to get like form three of the faces. And then through that again, we had 3 more faces, and we could begin stitching them together. So we actually took a galvanized tie wire and literally stitched up the seams of these 2 halves until we had this full wire cage. One last thing we had to do was add some support on the inside. Otherwise, the rock is so heavy, despite the steel being very strong, it will tend to bend, right? It's a malleable material. And so these steel ties, these are ties that you would find on a concrete work site. Just having those on the inside will take care of any of that. We found a pretty efficient way of shaping them. This was one morning we made about 5 or 6 gabions, and that was how much waste we had that entire morning. So it was pretty efficient. We learned an important lesson. I've included this photo in here because we assumed that with the larger gabion that it would be as portable as the smaller ones like this. Turned out not to be the case. When you're dealing with that much more rock and that much more weight, it can be pretty damaging to the steel if you try and move it. It's sort of a heart-wrenching morning the one day when we tried just that and we messed up all our gabions. But luckily we came across another strategy, which was to fill them on the wall. So we would take an empty cage, attach it back to the wall, and then fill it with rock and finally sew it with tubs. So it turns out to be a pretty good water-shedding material, and I think it turned out pretty well.
So there were many other products that were researched during the semester that did not make their way to the passive house, and I'll go through a few of those with you now. We did some work with cardboard. Here, the cardboard being used sort of stacked up and creating a chair held together by dowels, wooden dowels. On the right here, we have cardboard used as a light fixture. We thought it was interesting again, the light quality, the corrugations that you see through. Just an interesting effect. Super inexpensive material and what an example thing. So there's the cardboard. There's another sort of light fixture experiment with cardboard and string, and you see the large conduit here, which you can actually see in the passive house. The large conduit, which allows our light fixture to sort of swing from one area of the house to the next, so it's able to illuminate multiple areas and be adjustable to where you see fit, I guess. And here is just more experimenting with materials and their light qualities and where they can be applied in the passive house. We're following this as a series of beeswax. This is beeswax with a wire mesh. And it created sort of an interesting effect, almost a pixelated look with the beeswax, where it would sort of fill in and solidify and then leave open spaces. This is beeswax on burlap. Burlap is a recurring theme throughout the semester. And here is actually another sort of prototype, I guess, or experiment we did with the concrete and the glass. This was before we had access to the grinding material, the grinding equipment. So what we did was we cast the concrete in the glass, and then before it was fully cured, we sanded away to the surface of the glass to expose it, just with a wet, dry sandpaper. The reason that this didn't work so well for a countertop surface is you get all of those depressions. So what we ended up doing was filling in those jagged areas with the beeswax, and then scraping it off the surface. And then when covered in a 2-part epoxy or resin, which is what you can cover any bar top with, I guess, it's heat resistant. We did a few trials, and it's pretty scratch resistant as well. What that did was the areas where it had access to the concrete, it stained it a different color than where the beeswax was. So it created an interesting effect. And we actually have that sample here today, so you can come up and look at it if you'd like to when we finish.
There's also an interesting backstory to the Passive House, as you see it over here, and that was its former life as a granary in North Dakota. One of our classmates owns land out there, and they had a granary on their land that needed to come down. And so there's some photos in there of the original structure. We were able to salvage all of the cedar siding from that, which you see now on the exterior of the Passive House. The interior pine planking is also from that location, as well as the shelving. We took some of the lumber, we planed it down, resurfaced it, cut it to length. We took it to a cabinet shop and we joined them all. We took a biscuit joiner, a really simple process. Perhaps some of you are familiar with it. And fastened it all together, and it turned into this really great shelving. Another sort of unexpected material, of which there were many. So I guess any thought we'd like to leave you with is just that the materials that you see in the Passive House, they may seem at first glance to be sort of exotic or expensive, you might assume, but that's really not the case. So a lot of them came from just ordinary people working with them, really, and trying to bring out those real inherent qualities. We have some samples up here. I think that's pretty much it for slides, but if you'd like to ask us any questions or take a closer look, you're certainly welcome to. Thank you.